23rd, we will be talking about estimating population as soon as we wrap up 14.1.
Do you have any extras of 14.1?
Yeah. So, we talked yesterday about representative samples. What does it mean for a sample to be representative? Andrew? Yeah, but there's something specific that we have to make sure happens so that it represents a part of the population. Yeah, you're on the right track. You're just missing some details. Like, nothing that you said is wrong. You're just missing some details. Huh?
Is it like from the population, if you like simplify it down to get your sample, and that's representative because it's like a ratio.
So I like what you said, was simplify it down. There's one key word that makes a sample representative or not. Noah? Okay, so that's actually not the word I was talking about, but that does have to do with it. So there's bias that is involved. But that biased samples are non-representative. So they're representative or not based on whether or not it is
Valid? Equal? True? Proportional?
Who said it? Proportional or not proportional. So, when Manasa said it's reduced down, that's like saying, well, if I start with 12 females and 4 males, I could reduce down those values to 6 and 2, and these are equivalent fractions. 12 to 4 and 6 to 2 are equivalent ratios. So, we can think about it as being like a simplified down form, but what we need to care about that word, if on a mastery you were asked what makes a sample representative, hint, hint, nudge, nudge, you would want to be able to say that it must be proportional to the population. So, proportional to the population. That's what makes it representative. Yeah.
Our question is a little off topic.
Okay.
How come when you keep on dividing those down, it gets to 1/3, but that's not equal to that's not equal to 2?
It actually gets to 3 to 1. So if we look at
But how come?
it is. So
Oh, wait,
this amount of females compared to the amount of males is 3 times as many.
Yeah, I wasn't thinking about it.
6 to 2, 3 times as many. If I reduce it down 3 to 1, 3 times as many.
I get it.
Here, not 3 times as many, not proportional. Alright, so, when we're looking at would one person from each state be a representative sample if the study we're trying to conduct we're studying people who read newspapers. We're studying people who read newspapers. Like, there's a newspaper. Would a sample, one from each state, be representative? So we'd end up with 50 subjects in our sample, because there's 50 states. What do you think, Sam?
I don't think it would because that one person could not read it, and then that one person could read it. I think we'll need multiple, and just to figure out, like, we'll just need I guess an even number. Well, I guess just a better number than 1, because 1 is.
Well, yeah, but our sample would then end up being 50 subjects, one from each state. Tom?
I would say that it could work, but to make it less biased, you better be more people from one state. You might get someone that's like 50 years old, and the other state you could get someone who's like 10 years old.
Guys, if we're talking about people in the U.S., we're talking about millions of people, and we're only going to talk to 50 of them? So, there's a couple issues here. Not every state is the same size. So one issue is the fact that one person from one state is not really equal to one person from the other state.
You have to do it in percentile.
One issue that I think, Monica, you brought up was, do they actually read the newspaper? So it depends. Are we asking, do they read the newspaper? Are we looking for people who read the newspaper and asking them, like, what is it that you read in the newspaper? Do you read the sports section? Do you read the current events? Do you read the job section? Like, what do you read? But we don't even know if that one person is a newspaper reader. Oh, the other issue was that this is really small compared to the population. So 50 is not necessarily a small sample. If we took a sample of Phoenix students and we took 50 in our sample, bless you, that'd be pretty big. But compared to the population, that is a very small sample because of our population is U.S. citizens that read the newspaper, or if it's just U.S. citizens, we're talking millions of people. Sam?
What age is that for?
Not necessarily. I mean, if I'm a 25-year-old that reads the newspaper versus a 45-year-old that reads the newspaper, we both read the newspaper. So, any last questions from 14.1? Talking about what creates bias, when a sample is representative, all that good jazz. And Miles Davis. Anyone? Anyone? No?
What?
I said, and all that good jazz. Miles Davis was a very famous jazz performer.
I thought you were making a reference to the Chicago musical.
Well, and all that jazz really means like and everything else. It kind of means like etc. But it's. I tried to make a joke relating jazz. Yeah, Miles Davis, he's a sweet trumpet player.
I had no idea.
So when we talk about a population is the everything, right? So when we look at a situation, we have to first determine what is my population going to be. And that was a little bit unclear in that last question we just answered, because it said we're studying people in the U.S. who read the newspaper. It didn't it didn't clarify, are we asking, do you read the newspaper, or are we asking a question about the newspaper? So let's start to be a little bit more clear with what we're looking at and talk about how we estimate a population. We are going to estimate, and another word that we can use for estimate that we talked about yesterday is an inference. So we talked about inferences yesterday, are predictions that we can make based off data. So an inference must be based off of data. You can't just make a guess based off nothing. That we would probably use an expression like a stab in the dark. If you're making a guess based off nothing, it's as if you're trying to like kill somebody in a totally dark room and you're just it's not effective. So we need to use some data. Listen for where that person is. Turn on a light. Use some information. So we have a population of golf balls. We decide to go to the driving range. The weather's nice. I mean, it's like going to be 70, I think, today. Or 67, something like that. So we go, we'll probably be back with lunch. If the tables aren't wet, it might be raining.
Yeah, it rains.
So when you go to the range, you get a bucket of golf balls. And that bucket has 150 golf balls in it. You pull out a representative sample. You know that it's representative. Let's not dig into the why, but you just know it's representative. And what you see is 6 golf balls, 2 of which are orange, 4 of which are green. So I want to talk about the amount of orange golf balls in the bucket. I want to make a prediction of the orange golf balls in the bucket based off what I have. Well, what does the information that I have, the data that we see, tell me? Well, it's kind of done out on the paper for you. So it tells me if I compare orange to my sample, I've got 2 out of the 6, or a third of them are orange. So that tells me 1 out of every 3 will be orange. So I could say 1 orange compared to 3 total. So that doesn't mean compared to 3 green. It means 1 orange compared to the total. So if I then know that my total is actually 150, what would make this proportional on top of 50, right? Because 3 multiplies by 50 to get to 150, so there must be 50 orange. because when I reduced down my sample size, I saw that we had 2 out of 6, or I can convert that to 1 out of 3. That is 1 orange ball compared to 3 total. So if you take this sample and split it into 2 different samples, you have 1 orange compared to 3 total balls. Yeah, golf balls. So this tells me in general, if it's representative, which we are told it is, that I'll have 1 orange for every 3 balls that I have. So if I have 150 total, that takes a multiplication of 50. The same thing has to happen on top, and we just get 50. I want you to predict the green balls in the bucket down here in the open space.
That's kind of awesome.
I know, but we want to show the work to support.
Oh, okay.
So if we were to set up the original ratio that we would get when predicting green, we want to set up green over total. In my sample, what do I have for green compared to total, Elena? In my sample. How many greens are there in your sample?
4.
4. How many total balls were there in your sample?
6. Yes.
6. So that can reduce down to 2/3. So that tells me the portion of my population that is green is 2/3. So 2/3 of the population is green. That whole sentence is math. 2/3 of the population is green. That statement is math. When I do that, and as Monica told us, it's pretty simple. If I had 50 orange balls, then I end up with 100 green. So obviously that one's a little bit easy. We want to start you out with a manageable one. Yeah, John?
Couldn't you have just taken 150 total balls and subtracted by the 50
Yes.
non-orange balls and gotten
Yep.
your...
But every situation will not work out that easy.
Okay.
So this is making sure, no, thank you for the reminder. This is making sure that you understand the process. So, sorry, I did not think to capture that. So try that here, all you captains of couldn't we just.
Sorry.
No, you're good because you're right. But the funny thing is, you guys have to realize, like, yeah, that one's super easy on purpose. We then take it to the next steps.
Okay.
Our population of a certain town in the future, we're still 200 years in the future, is 13,500 members, not beings or humans, because we have robots incorporated now. So look at your sample. This is our representative sample.
Which ones are robots?
The metal guys with the red eyes.
The ones that.
Okay.
So
I mean,
these
it's
guys
not-
just look futuristic-y. They're wearing futuristic clothes. But these guys are your robots.
Okay.
So you have 2 robots. Depending. If you've watched the show Humans at all,
Yes.
you'll realize that will actually create a distrust. Because if you make robots look like humans, then humans will start to distrust other humans, thinking, what if they're a robot? So you walked into class and you couldn't tell if I was a human or a robot, you might not know, like, what I would be, like, what I might do, because if you don't trust machines, and you can't tell, am I a person or a machine, that gets a little dicey. I'm not a robot.
Exactly.
So the question is, can robots lie?
It's something just a robot would say.
Did you take your heart medicine today?
That is something that just a robot
Why
would
would a
say.
robot have a heart? It just makes sense. If he takes heart medicine, why would a robot have a heart?
Maybe
But the
this isn't heart
humans
medicine,
have
maybe
bright
this is
green
a
eyes, so
fuel
it's
pump.
kind of obvious.
Maybe this is my energy source.
Here, let me take I'll be the Tesla.
It will regulate your blood pressure.
Wait a minute.
Alright.
You're gonna get water. Robots can't drink
We're way off topic. Mr. Williams, we know that we have humans and robots, right? We only have 2 things in our population, which makes it nice. The more things we have in our population, the harder it gets. We're trying to estimate the number of robots. So how would you start building a proportion to work with? What can we say based on our sample?
So 13.
Shoot.
And
will you multiply the sample, small sample, and
So we need to pull some info out of the sample first. You're right. We're going to end up doing a multiplication.
then there's 8 kids, 8 children, 8 humans, and 2 robots.
All right. So 8 humans and 2 robots. So this number given to me is everyone. That's a total. So I also need up here to talk about a total.
So would it be 13,500 over 10?
Now be careful. We want, chill, he could actually set it up that way. We could make a proportion work that way, but that would be a little bit harder to understand. So what we want to know is we are going to set up a proportion from the sample. So we're going to have sample data over sample data and relate that to population data over population data.
So 8 over 2.
Be careful. The data that we care about here is the robots. So not 8 over 2. Instead of using the 8 over 2, we're going to use, not 8 over 2. We're comparing robots and total, right? Because the two things we care about are robots and total. So I want to compare robots to total. What would that be for my sample?
It would be 2 out of 10.
2 out of 10. Robots compared to total. So now this will be robots in total out of the population. I don't know how many robots there are in the population. So I'm just going to make that an R. Jeremiah, how many do I have total in my population?
13,500.
Yeah, in this situation, my population is 13,500. So make sure my top agrees with my top, robots, robots. Bottom agrees with bottom, total of everyone, total of everyone. This is just total of everyone's sample, total of everyone's population. We can cross multiply and solve if we want. Or the other way to set this up is a fifth, if I reduce my 2/10, a fifth of my population are robots. You know how to set it?
Yeah, that's what I did, and
Okay.
I'm looking at it now, and I realized it probably would be easier just to keep it as 210 because 10 is easy to work with, like with 13,000.
10 is easy to work with. So I could do 1/5, or if we want to leave it as 2/10, and here we'll show
That's
why
what
2/10
I did
is
it with.
easiest.
I did it with 1/5, and it seemed like it probably did a little bit more work than I needed to.
Every number is really a fraction. Every number that we deal with can be written as a fraction. Because we've not dealt with imaginary numbers or anything like that yet. I can quickly divide by 10. Because if I have a 10 on the denominator, I can divide this by 10 by just chopping off a 0. And then I get rid of that. Now my comma's obviously in the wrong place now. But what I'm really answering is what's 2 times 1350. Well, I can double all this and see that I get 2,700 with my comma in the right place. So I'm going to put back the 10 and put back the 0 so it looks like it makes sense. But that tells me 2,700 robots in my population. So the show Humans is hypothesizing a future where you have robots as an assistant. So essentially, they are your AI to do whatever you ask them to. So like, go pick up my laundry for me, go to the grocery and buy these things, go walk my dog. Like,
That's a bad idea.
That
it is
seems
a
like
terrible idea.
humans would be so lazy.
So, if you would like to talk, I love these conversations. If you want to talk more about robots, let's talk at lunch or break. We gotta keep moving. So, try this on your own. I'm gonna give you like a minute, maybe. Sample of 24 7th graders. That seems important. There are 3 with April birthdays. I have an April birthday. I'm not a student. If there are 480 students, hey guys, unless you have an answer yet, we shouldn't be talking. Jaslyn, what's the important information that we're going to pull out of my sample? What's the sample data that we're going to use?
Well, we know that there's 24 seventh graders, and out of the 24, 3 of them have April birthdays.
So, yeah.
It's 3 over 24.
My sample data tells me 3 April compared to 24 all, or total, or whatever you want to say. I can do percentages with this too. If we do a percent here, we get that 12.5% have April birthdays. Right, because this reduces to 1/8. And we know 1/8 comes out to 0.125. We remember that conversion, which comes out to be 12.5%. This is another way that we could solve this. Instead of a proportion, and instead of multiplying with a fraction, now, if we know that 12.5% have April, I did the division, and then I converted to a percent. Then what I can do now to find that answer is just say, okay, well, 12.5% of everyone will have April birthdays. Now the problem is that 12.5%, I can't actually use the percent. So if you're going to go this method, you almost might as well just leave this as a decimal, because this multiplication that we have to do is really 0.125 times 448. And it gives me that in the 7th grade, we would predict there to be 56 April birthdays.
55 points. No, sure.
You cannot have a partial birthday.
No, I know. That's what. Yeah, I know. You
Half birthday.
You can have an unbirthday.
Half
What's an
birthday.
unbirthday?
We have lots of unbirthdays.
Oh, wait, not have a birthday. Wait.
Oh, it's an unbirthday.
I would make a birthday too.
So being born on a leap day, they just normally celebrate their birthday on March 1st the next week. To who? Any questions on that? You can solve this many different ways. You can use the fraction, you can use the decimal, you can use the percent if you feel like it. How do we know that there's a constant of proportionality? Ooh, that big word that we haven't seen in a while.
No, I forgot. Constant.
Between a representative sample and a population. So we have to remember, how did we find our constant of proportionality? Remember, that constant of proportionality was actually the m in the equation y equals m times x. So that constant of proportionality value, this m, if I wanted to get it by itself, what would I get rid of? How would I do it? So if I divide x, really my CP becomes y divided by x, which in this case will be the total divided by that characteristic. Whatever characteristic you're looking at, just because the y and the x. Now we could flip this, and still it'll be like, they'll come out to be proportional. But think about if I go back up to,
So the total is equal
so give me a second.
to the characteristics.
So remember your 56 April birthdays.
Yeah.
So if I come back to here, my April birthday problem, and I compare 24 to 3, that gives me 8. If I compare 448 to 56, the total divided by the characteristic that we were looking at, we'll get right about approximately 8. If I flip this over, and I do 3 divided by 24, I'd get 1/8. If I flip this over, I'd get 1/8. So when we do the division, how we know this to be true is when we divide part divided by whole, or whole divided by part, we get the same values.
Yeah, but in constant proportionality, the y divided by x is equal to total times the characteristic, which is study.
Yeah, like what? So the characteristic in this situation was April birthdays. because we have to be studying something. So that's just whatever you asked about. N is just a letter that represents constant proportionality. So we dealt with that back in proportional relationships. When we have a proportional relationship, so we could say two different things here, Monica. And this is where, like in math, you have options, and this makes it dangerous. You with me, gents? We could say two different things. We could say the amount of April birthdays are 1/8 out of everyone. Or we could say the everyone birthdays are 8 times the amount of April birthdays. These are not the same, but they both represent the same situation. This is my output being April birthdays. This is my output being everybody, like all of people, all of birthdays. So it depends which one you want to use, whether you want your output to be April birthdays or whether you want your output to be all birthdays. They're reciprocals. One of them, not both. You have to choose which one you decide. Whether you're doing part divided by whole or whole divided by part. It's up to you to make that choice. Alright, so botanist. What's a botanist do? Well, what is botany? Yeah, plants. So, he wants to find the number of 4-leaf clovers in a certain field. Now, this guy's got way too much time on his hands. There are people that do jobs like this, but they don't do it with 4-leaf clovers. But he has counted that there are 700 clovers in the field. Let's hope he used like a drone or something to make his life easy.
Oh my god.
As he walked through, or she has 3 samples. Ooh, now we have multiple samples. Ah, crap. This is one where I am dependent on Pearson and I don't have everything in the notes. Skip this. We're going on to the guide. We'll come back, potentially. I'll have to choose some values for that one. So we are looking at fiction, nonfiction, reference materials, poetry, drama, children's books. We're looking at all the breakup of the library. I asked 3 of you to go out and pull a sample of books. So Dom comes back. And he's like, here you go. I got a fiction, a children's biography, a fiction, a nonfiction, a poetry, and a play. You just got to stay. And Sam comes back, and she's like, Dom, you're so good. I got 12 fiction, 15 nonfiction, and 12 biography. Dom was an overachiever.
I'm an overachiever than Sam.
So Moon comes back. She goes, I had to show Sam up. Moon got 40 fiction, 29 nonfiction, 7 poetry, 19 drama, and 39 children's books.
How?
How did you manage
What
that?
we actually know. Hey, hi. What? What we actually know is in the library. There are 1,500 fiction books out of 5,000 total books. We know the population data. So, somewhere, let's go ahead and start notating. We have population data. And if we do our part divided by whole here, we're going to be doing fiction compared to all books. And my fiction compared to all books would be 1,500 divided by 5,000. I can chop off zeros. Excuse me? That's all we know from the population. That's the only thing we know. So the samples, it doesn't matter what I got from the sample because I've been given population information. So this comes out to be 30% or 0.3. Chop off the zeros and I get 15 over 50. Double it, you have 30 over 100. 30 hundredths, 0.3. Or, yeah. I don't need this extra 0. So this reduces to 15 fiftieths, which can become to 30 hundredths. If you want to just, or, okay, so this could become 3/10, but I always think in terms of hundreds because of money and because of percents. So my brain just defaults to how can I make my denominator 100? Same answer.
Yeah,
So it doesn't make a difference
the fiction is
because that's how my brain defaults. It's not right or wrong, it's just how my brain defaults.
okay.
I always am searching for 100 on the denominator. That's normally easier.
Yeah.
This won't always work out. So sometimes you just gotta go for that. Now, so what we know is 30% of our books are fiction. Which is probably about good for a library. You gotta have some fiction, some non-fiction, whatever. We need to figure out whose sample is the closest to being representative. So,
It was mine.
if you want to capture this, let's try Don's sample. How many fiction, so we'll do sample A over here, how many fiction compared to total? So let's go through. Well, okay, we've got fiction here and fiction here. Okay, so we've only got 2 fictions compared to,
5.
I would really rather that be blue. Now be careful, how many total books did he grab?
My total grabbed 7.
You think about it, we're talking percentages, we're talking proportions, we're always talking about part compared to whole.
Oh, so then.
We do not compare a part to part, because that would be inaccurate, that would skew our data. We're always talking about part compared to the total. So this would be 2 7s, which if you remember the crazy cool 7 relationships, this would be 0.285714. Don't worry, I've been at this much longer than you guys. I just think the 7s are really cool. Because remember, this is twice 7, 4 times 7, kind of 8 times 7, not quite there. That's why the 57 kind of boosts it up. It would be 56 if you wanted it to be perfect. But like that's what the actual value is. And this repeats, so we have the
We
dot,
got
dot, dot.
approximately 29.
Yeah, so close to 29%.
Good friend.
Sample B, what Sam brought back, we can easily see she had 12 fiction compared to, well, 12, 12, and 15. 39. 12 divided by 39, I do not have this one memorized. That one's a weird one.
130769238.
Wait, what?
Yeah.
Thanks, Ozzy. That really craved himself.
I'm surprised.
I'm a cousin.
I couldn't remember the 70s.
Because it's a beautiful relationship. I'm serious. Like, the relationship they create is just beautiful. And that's why I'm able to remember it. Because I think it's cool. C, we can quickly see that Moon brought back how many fiction?
40.
How many total?
136.
136. Somebody verify that, please. Check those, add them up. Not that I don't trust you, just I did not add them up, so I don't know. If I do that division,
134.
134. Alright, we need a third party. Add up all your books, figure out how many our total is.
Okay.
Third party
40.
verification.
Plus 29.
So we have 69, 76,
It's 134.
86,
134.
95.
I got 134.
Yeah, so did I.
Who said 136?
Dude, it's okay. Small math mistakes happen.
Yeah.
So this division gives me 0 point, or 0 and 298507. Don't know.
Wait, that's a song. I know that song.
No, you're talking about 8675309. Jenny, I got your number.
No.
It's a classic song. Jenny.
That's a great song.
It's called Jenny.
So B wins.
I think it's actually called 8675309.
I win! No!
Yay!
So, hold up. If we are trying to be as close to 0.30, 30% as possible,
Actually, probably not.
this, if I only go out 2 decimal places, well, this would round to a 9. So that's like 100th off, probably, or 15 thousandths, if we want to be that technical. This would potentially round up to 100th off. And this,
Ooh, that's
the 8 would round the 9 up.
Oh, no!
So our best sample.
Thanks, fam. Yeah. Appreciate it.
Now, how we want to label this is most representative. It's not perfect, but it's close. It is the most representative. Because it's the closest. If we did the subtraction, the difference between each of these, this decimal value is the closest to 0.30. Even though these are close, they're not closest. This is my best sample. Not saying that these samples are bad, they're just not as good.
So about the songs, that is the actual song. I'm not talking about like the Jenny one.
Okay.
Because I was listening to a podcast on
Okay.
Radio Lab and it was talking about numbers and that was the song.
It was talking about numbers.
Like how we view numbers, like
If you can find it again, send it to me.
Do I get a participation award?
No, we don't give those out here. You get awards for winning. Alright. So now, let's say we've got Jaslyn, Elena, and Whitney working at a computer factory. So they are now tech gurus. They're out in Silicon Valley making lots of money. And they are inspecting a new device that they're rolling out. A new computer. Now, it's got 670 in storage. And each of the inspectors checked 50. So each of them made a sample that was 50. They checked 50 computers. Now, each inspector used his or her results to estimate the total number of defective computers in the factory. So, wait, they used it to estimate. So we know they each checked 50. So we look at like Inspector A. He got 4 defective computers. If we were to set this up as a ratio, what would that be 4 out of?
50.
Why?
Because each inspector checked only 50.
They checked 50. That's their sample size. So this would give me 0.08. Again, I'm thinking about how can I turn this into 100 and I get 8 hundredths.
Oh yeah.
That's easier than trying to divide by 5 because 4 does not divide by 5 very well. Inspector B got 1 out of 50. Or again, if I turn my denominator into 100, I get 2 hundredths. And Inspector Gadget got 2 out of 50.
Inspector Gadget.
Using about 4%. So, to figure out who was accurate, well, they both, for their sample, they each got true data for their sample. But if we find out that there are actually 29 defective computers in storage.
I would fire them. Somebody screwed up then.
No. Their samples were only out of 50. That's 29 in storage.
Oh my god.
So if I want to look at the ratio there, what ratio would I set up for that?
Fire 29 over 670.
29 over all of them. That's approximately 30 over 660, which I think is going to be like 1 ish, like 5%. Who's got this?
0.0442858.
So, whose estimate was the most accurate?
Number C.
Number
C.
See the baby. Jay, wait, who was Inspector Gadget was the best?
Which
Because
one?
he's got all those
That was
gadgets.
which one of us was C? That was
It
me.
was
It was me.
me.
You said
Well, I
my name last.
Whitney last.
Yeah.
So, I think
Woo!
Whitney wins this
Hey
one.
Whitney, Mary.
All right.
you can do-
Thank you guys. You should be able to do your homework now. Tomorrow we will continue on with this stuff. We will have no mastery. So yeah.
Should we meet?